Hello, my name is Ramiro Cuenca and I'm a motion capture specialist at the Sawmill. In this tutorial, we're going to be taking a look at PeelSolve. In a previous tutorial, we took a look at the cleanup tools for PeelSolve, which is similar to Blade, and we can use it to clean data, jitters, occlusion, swaps, and all that kind of stuff that we can encounter in mockup data. So today we're going to be taking a look at solving into an actual 3D rig. I have here a range of motion that has already been cleaned. So it's a basic one. So we're going to start with the solving process. Again, make sure that your plugin is loaded. If not, nothing's going to work. So the first thing that I'm going to do is to check that my scene is at 24 frames per second or 30 frames per second, whichever you're working on, because when we clean data, it comes in at 120 frames per second. So just change to whatever you want. Okay. Now we're gonna import the rig. I'm just gonna use a generic basic model. And I'm just going to use a namespace. Okay, so here it is. Now the first thing we notice is that the rig is bigger in scale than the point cloud. This means that the actor, it's not the same height as the rig. This is very normal. Only in really really big production is when they scan the actor and make the model based on the actor, so that makes it easy, but it's not all the time. So the way we do it is we need to reduce the scale to match the actor. So what are we gonna do to do that is we're gonna create a locator. We're gonna call it reference, and we're gonna bring in the skeleton, only the skeleton and not the geometry. So you should have something like this. So now the reference is the one we're going to scale up and down. So you can grab all, and if you middle click and drag, you can make it bigger and smaller. And only use the reference to scale and use the hip to move the rig. So don't confuse these two. Reference only for scaling and the hips for positioning. So I'm just gonna go and quickly scale it to what I think it should work. So this is centered. Now I go to the front view and I grab the reference and I'm gonna scale it down so it matches there. So 0.93, and I'm just gonna center again the rig. Okay, be very careful in the position of the rig. It's very, very important to spend some time and really nail those markers to where the actual actor. So the things that I look for is shoulders, so that the shoulder joint are aligned or are a bit close to this. Also, if you notice, the actors, it's rare that an actor is doing a really straight T-pose, and as you can see here, the rig is completely straight in the axis, but we can see a slight tilt here. So that means the actor was rotating or looking another way. So I'm just gonna rotate slightly the hips on that axis just to match a bit that direction. and again try to position. Okay. So now the first thing that I'm gonna do is I'm gonna align the feet with the point cloud. So first I'm gonna start, I'm gonna work with axes, like individual axes. I don't like to do this too much to position it because you have weird values here when sometimes you don't need them. So I'm gonna start with this axis first, and I'm gonna try to align this joint to be in the middle of these two and point it at the tip of the toe. Yep, like that. And then I'm gonna rotate on the back, and I'm gonna make sure that this angle is pointed at the heel and it's center here. So I'm just gonna slightly rotate it there, but that seems that it's fairly okay. I'm just gonna move it a bit so it's center there. Then I'm gonna go to a side view. Now I'm gonna grab the x-axis and I'm gonna bring it forward just a tiny bit, because the sheen marker has to be in the middle of the sheen joint or a bit on the back to drive it. Also, the ankle joint should be pointed at the ankle marker, something like that. So now we have the hip coming here, pointing this, and then this point at that. So now I'm gonna make sure that my feet didn't got offset, which is fine, and still pointing there. So now I'm gonna align it with the ground plane. I like to hit 4 to see this view, and then I'm gonna try to match this, the geometry, so it's flat on the ground. So and you can see here how kind of like everything is flat. So yeah, happy with that. And I'm gonna go to the other foot and do the same thing. Okay, now what I'm gonna do is I'm gonna lower down the hip so the marker, so the feet are aligned with the floor. There we go. Okay. Now that I have the feet aligned, I'm gonna start and applying the constraints and everything that PeelSolve needs to move this rig. I'm not gonna worry too much about the upper body just yet, because it's really hard on a T-pose to know the rotation of the shoulders, if it's rotated in or out, or if it's higher or down, or if the actual spine is the one that's rotating. It could be like this. So feet are the first step, then applying all the constraints, and then once we have everything connected, we can fix the upper body. So I'm gonna start doing that, which is I'm gonna start applying the constraints and basically connecting everything that PeelSolve needs. So the first two that I'm gonna use is the position constraint and the orient constraint. The position constraint it will make the joint to follow only positions, only translation, and the orient constraint only in rotations, just as a normal constraint. So I'm just gonna hide the body just quick so I can see. And the first step that I'm gonna do is I'm gonna select the hips, and then I'm gonna click on this button that is set. The thing that we're doing here is we're telling PeelSolve which rig to move. If you're trying PeelSolve and you see that nothing works, make sure that your root nodes are defined. If not, nothing's gonna work. So just select the hips and then click add, and you'll have it there. Also, for this setup, we're gonna do a basic default setup that works with pretty much most of the data. PeelSolve gives us a lot of freedom to connect constraints to individual joints, so there is not one single way of connecting or attaching a rig. This is just the way we do it here, and it's a default one. So the first thing, I'm gonna start connecting the feet. So the way we do it is we select the marker that we want to constrain, and then the joint that it's gonna be following that constraint. So click marker, then select the joint and hit position. And then you see this little thing, this little line connecting, and if you just change the size to 5, you can see how the constraint works. So I'm going to continue with the rest. You can select also multiple markers for one single joint. It doesn't necessarily have to be one marker, one joint. And one marker can be driving multiple joints too. So I'm going to select the outer and inner foot markers and the heel marker, and I'm going to connect it to the foot joint. Make sure these 3 are to the foot and the toe to the toe. Then I'm going to do the same thing for the other. And now what I'm going to do is I'm going to go here, PeelSolve, and before you click, if you hold Control Shift and then click the button, it will create a shortcut in your tab. So I always use this active, and I'll explain why. So just Control Shift and click, and then you'll see here, appear in here. This way you won't have to go and do this all the time. So what this does is it selects all the constraints that are attached to this rigid body, to this skeleton. So I select active markers and it selects the joints. So what I'm going to do is I'm going to change the size to 5, so they're visible, and then the translation weight to 2.5. I'll explain what this translation weight does in a bit. Now that I'm done with that, I'm going to continue and attaching the other markers. So the shin marker and the ankle marker go to the shin. Then these 2 markers go to the leg. Oops. Then the hip markers, the 4 of them, go to the hip. Now I'm gonna use these 2 again, and I'm gonna use them to drive this spine, and also these 2. So here we see how these 2 markers are driving both the hip and this joint. Then I'm going to connect the front one to this one, and this middle back to that back. Then I'm going to connect the 2 shoulder to the shoulder. Then this 1 marker to the other shoulder. This is the clavicle, sorry. So shoulder to clavicle, and then this one that we have near the bicep goes to the shoulder. The one that we have on the forearm goes to the elbow joint. and the 3 hand markers go to the hand marker. Now for the head, we're gonna select these 3 markers and we're gonna view a new button here, this X. This will create a rigid body. So it's as easy as that. So we create a rigid body. Then you see, so we're gonna use this rigid body to be driving the rotation of the head. So in here we're gonna use the Orient constraint. So select the rigid body and then select the head marker and Orient constraint. You can also notice the difference between the Orient constraint and the position constraints because they have the position constraint has a blue ring around and the Orient constraint is yellow. Then what we're going to do is we're going to select the 3 head markers again, but instead of creating a rigid body, we're just going to position constrain it to the head. Okay. So now I'm going to select the markers again and change the size to 5 so we can view all the markers. Nice and easy. Okay, so this is the first step, connecting everything to where it's supposed to be. Okay, so now that everything is connected, we're gonna make sure that the rig is actually moving. So I'm just gonna show the body again. And the way we can do that is if you just scroll through, I'm just gonna use this, that it's a major change. And if you hit test, the rig should follow and acquire that position. Okay, so now we can see that still this is not correct. You can see the line here and the shoulder popping, but that's okay because we haven't, as I said, we haven't fixed the upper body, but you can see how the legs are fairly doing what they're supposed to be doing. But this is good. Now we made sure that everything is connected, so we can now start fixing the back. So I'm gonna go back to my T-pose and find where she's bringing her arms in and out. This way we're gonna fix the shoulder rotation. Here it's easier for us to see what it needs to be doing. So the first thing that I'm gonna do is this is very important because if not, any change you make, it won't remember it. So select first active markers and then this lock button. So, and the way you can see it, you can see all the markers. So what it's doing now, it's saying, okay, hold, like lock these markers because I'm gonna move them around a bit. So I don't want anything to change except what I'm telling you to change. That's what we're saying to PeelSolve. So once that's done, I'm gonna start fixing the shoulder, and we can already see that it's rotated down a bit. So I'm gonna go to my top view and then just make sure that this shoulder marker is on the back. And I'm gonna do the same here. Okay, now I'm gonna go on my perspective view and I'm gonna align this joint to the middle of that marker. There, and I'm gonna do the same thing to the other. There. Now I'm gonna go again to my top view and bring the joints in and try to align it so the joint is in between the hand markers. And now I'm just gonna rotate an X to align it with those markers. That's it. Okay, and then once I'm happy with this, I'm just gonna unlock them and hit test. And now if we scroll through, we should have a better solve. So now the arms are following the rig better. You can still see here that it's crooked. And now we're gonna be fixing all the joints. So we go back to our T-pose, and then what we're gonna do now is we're gonna do the same thing again, select the active markers and log them when we're working with them. So what I'm gonna do is I'm gonna assume the preferred angle of the okay, so now we're gonna do the last bit. So we select again the markers, log them, and what we're gonna do now is we're gonna select the two elbow joints, and we're gonna we're gonna zero out and lock the x-axis and the y-axis, because that's how this joint moves. It only moves on the z-axis. So zero that out, and we're gonna lock selected, and we're gonna do the same thing with the shin and with the toe, but we're gonna lock the z-axis and the y-axis. Okay, so now I'm just gonna rotate my wrist in and down a little bit. Okay, and now what I'm gonna do is I'm gonna select these constraints on the upper hand, and I'm gonna click here on this button. What it does, it will remove the offset, or it will set a new default position, and you can see how now the markers are circling. I mean, the constraints are circling the markers. So the next thing I'm gonna do is I'm gonna select the spine joints, the neck, the head, and the shoulder, and I'm gonna hit this attribute button. And we can see here how now we have a lot of attributes that we can play around. So we're gonna be playing around with a few. The first one is the rotation stability and rotation stiffness. So we're gonna select the spine markers again, the spine joint and the shoulder joints, and we're gonna add one on stability and one on stiffness. Then we're gonna select the last spine joint, the neck and the head, and we're gonna turn the rotation shared value on. Now select the head and the rotation shared value. We're gonna be distributing the values between these three joints. So the head, since it's the top, it gets the full value, which is 1. Then the neck gets 0.5, and the spine doesn't get anything. This will give us a nice rotation from the head to the chest. Now we have that ready, we unlock the markers again, we hit test, and we're just gonna try it out. So it looks like it's working a bit better. maybe not there, but this could be because I'm just skipping to that frame, and since it's a difficult position, PeelSolve doesn't know how to get it all straight from there. But he may be able to do it if we do the solve. The last thing I'm going to do is I'm going to select the head markers. I'm going to bring them down a bit, and I'm going to change the translation weight to 0.8 to reduce the weight on the head. Now that it got a bit crooked, I'm gonna align it. So again, select the active markers, lock them, and what I'm gonna do is I'm gonna assume prefer angle, which resets to its neutral position, and I'm just gonna fix it a tiny bit. Okay. So now what we're gonna do to actually test the rig is we're gonna hit this run button. So what this run button does is it's gonna be playing frame by frame, and then what it does is if this marker moves, this constraint has to move to be always circling the whole marker. So we can see it here in small increments, how it's always gonna be trying to move and reach that optimum position. So that's how it works. So if I hit run, we can see the whole thing going, but it takes a lot of time because it has to display what it's doing. So I'm just gonna select the outliner and hit run, which will do it faster. Okay, so once the process is finished, let's check what the data. I'm gonna show only the geometry so we can see what's actually going on. Alright, so with this we finished this tutorial on solving motion capture data into a 3D skeleton rig. I hope it's useful. So see you next time.